This is the next math lesson, and I have two special guests here. Can you say hello, Chloe?
Hello.
Can you say hello, Madison?
Boo.
Yep. We're off to a good start. Okay, so it's 3:20 as we can see right here on the clock. The ice cream will be ready in 60 minutes. The bells will ring and the lights will flash at 4:20 because that would be 1 hour from 3:20 to 4:20. That means if Fred would start speaking at 4 o'clock, he would be able to speak for 20 minutes before the great big event. And of course the big event is the ice cream will be ready. Yum. It doesn't have sprinkles. That's pretty cool. And over 100 people had arrived at the Pi 1 for the Math and Pizza Conference. Okay, on the north side of the room, over here, we know that north is up. North side of the room, people had set up booths to sell things at the conferences. And one of the most popular booths was the pizza button booth. And the pizza buttons were 9 cents each. And almost everyone stopped and bought some of them. They look like real little pizzas, don't they? Joe bought one. He was going to use it to bait his hook when he went fishing. I don't get that at all. Why would you use a button to catch a fish? Anyhow, he paid a dime and got a penny in exchange. So Joe paid a dime, which was 10 cents. The buttons are 9 cents, so we subtract 9 cents, and so his change back from the person running the booth would be 1 penny, 1 cent. So Darlene bought 10 buttons, and that would be 10 times 9 cents, because they were 9 cents for each button, and that would be 9 times 0 is 0, and 9 times 1 is 9, and so she needs to pay 90 cents. So she's going to hand the booth person $1. How much change will she get back? So now we have to subtract 90 cents, and because I have a dollar here with a decimal point, I'm going to make my going to have to use a decimal point here. So this is 90 cents. It's less than a dollar, so it is after the decimal point. And I have to subtract 90 from a dollar, and I'm going to end up with 10 cents. And so she is going to get 10 cents, or a dime, back as change. So let's real quick just go over, I know you know this, but let's just go over the amounts. A quarter is worth 25 cents. I can write it with the 2, 5, and the cent symbol. If I'm going to use it in a math problem, I would use the 2 and the 5 would go after the decimal point because it's less than a dollar. A dime is 10 cents, 1 0 with the cent sign, or 0.10 if I'm going to subtract it or add it or anything. A nickel is 5 cents, that's 0.05. A penny is 1 cent and 0.01. Now, Darlene, she wanted to sew the buttons on her wedding dress. She has bought a wedding dress and she wants to marry Joe, but she hasn't told Joe yet. And of course, Joe doesn't know it, so Joe hasn't asked Darlene to marry him. So that's how she's going to decorate her wedding dress, with pizza buttons. Sounds weird. Now, Fred, he bought 7 pizza buttons, and he paid $1. He liked the way the pizza buttons smelled. And that's one gigantic nose coming at you. Yes. Whee! Gross. So Fred bought the 7 pizza buttons, and he paid $1. And 7 times 9 is 63 cents. If you know your 9 tables, 9 times 7 is 63. We also know that it's 9 times 7. That means that this answer, because that's a 7, is going to be a 6. And then the 6 plus what equals 9 has to be 63. Now, there are 3 ways to figure out how much change Fred should get back. Okay? Way number 1 is he writes out the dollar as on here. I just wrote it as 100. I didn't use the decimal point. Minus 63 cents equals 37 cents. So he used a pen and a piece of paper, and he could figure out how much change he should get back. Way number 2 is you use a calculator. Okay? And you would type in 100 minus 63, and then the display will say 37, and you would know that. The third way is you count back the change. Now, at the auction that I was at, that one big one, I was talking to some of the kids and telling them that you had to count back the change, because that's the easiest way. If someone gives you $1 and you know their total is 63 cents, instead of having to subtract anything, you basically start counting back. So they gave you $1. Their order came to 63 cents. So now you start counting back. Okay? And you would go using 2 pennies. So this is a penny. You would go 64. Another penny. 65. Now you would use a dime. And a dime is 10 cents. So 10 cents added to 65 cents would be 75 cents. And now you get a quarter. And you hand that back, and that makes $1. So in this method, you're starting with what their bill was, the price of the buttons. That was 63 cents, and now you start counting back until you get to the dollar that they gave you. So they owe 63, so you start with the very next number. A penny to get to 64 cents, a penny gets you to 65 cents, a dime gets you to 75 cents, and I know that a quarter will get me to $1. And then when I hand them the quarter, I say $1. And now I have counted back the change, and that's the most professional, most accurate way to do it. When you got to make change, you don't usually have time to write it down or to grab a calculator. Okay, Stanthony bought 8 pizza buttons, and he paid $1. So now we have, in the amount of the purchase, we have 8 buttons times 9 cents, and that's going to be 72. Once again, 7 is less than 8, and the 7 plus 2 equals 9, so I know my answer's right. And now I need, the purchase price was 72 cents. 72 cents. So we're going to count up from 72 cents all the way to $1. So I'm going to need 3 pennies, and I'm going to go 73, 74, 75. When I'm at 25, 50, and 75, I know I can use a quarter. Okay? So now I can use a quarter, and when I hand him back the quarter, I would say $1, because the quarter added to 75 cents makes $1. So again, he owes me 72 cents. He gave me $1. I count back. Not at 72, but the next number, 73 cents, 74, 75, and a quarter makes $1. And that would be his change. So Alexander bought 2 pizza buttons and paid $1. And 2 times 9 cents is 18. Again, I know that my answer is right because I have a 9 here. That means that my answer is going to start with one number less than the 2, and my answer here, 1 plus 8, has to equal 9. So he owes his fee, his purchase price is 18 cents. He gave $1, so he's going to have a lot of change back. So let's start with, we're at 18, so we have to do pennies. So we do 8, we say 18, and then we start counting up. So this is 19, another penny is 20, and now I'm going to give a nickel. And that will get me to 25 cents. And now I'm at 25, I know I can use a quarter, because if I have, when I'm at 25, 50, and 75, I can use quarters. Okay. So now I'm at 25, and I'm going to add another quarter, and I'll say 50. I'll add another quarter, and I'll say 75. And I'll add the last quarter, and I will say $1. Okay. Okay. Betty is buying 3 buttons. 1, 2, 3. She's going to pay $1. We know that 3 buttons times 9 cents is 27 cents. We know that 27 is the right answer because 2 is 1 less than 3. And 2 plus 7 equals 9. So 27 is the right answer. I'm going to say 27 out loud, but I'm going to start counting up with the next one. So I say 27. I give the Betty back a penny, or give her a penny and say 28. I give her another penny and say 29. I give her another penny and say 30. I give her a dime. I know that when this is 30, if the amount is at 10, 20, 30, 40, 50, 60, 70, 80, 90, I know I can use a dime. So I'm at 30. I give Betty a dime and say 40. I give her another dime and say 50. I know that if I'm at 25, 50, or 75, I can use a quarter. So after I say 28, 29, 30, 40, 50, now I give her 1 quarter and say 75 cents, and another quarter is $1. Okay. Okay, so now we're going to do a timeout, because the best way to practice counting back change, which is something you will need your whole entire life, you also want to make sure that people are counting it back to you so you don't get ripped off. The worst thing in the world is you go through Sonic or Taco Tico or Benny's and you hand somebody $20 bill and they give you back a wad of money and you don't know anyway. You'd have to sit there and count it by yourself. So they should always count it back to you too. So we're going to take a time out and we're going to practice counting back change. What you need to come and get from me is 4 pennies, 4 pennies, 1 nickel, 2 dimes, and 3 quarters. So each person is going to need this so that you can practice with each other. Okay? And let's see. So let me go to the next screen. Assume you have your money. And now I'm going to give you amounts that for you to practice counting back to. So if you practice in pairs, then you can, one person can be the person buying something, the other person can be the person that was manning the booth and counting back the change. Okay, so in pairs, and let's do, well, I don't care how you break up, but one person will do one, and then the next person does the other, and then you just keep taking turns counting back change for each other and making sure that you can do it. So an interesting fact, every coin has "In God We Trust." on it. Every coin has liberty on it. That's okay. Sorry about that. That was my phone. Every coin has liberty on it, and liberty is not the same as freedom. Liberty means a special kind of freedom, freedom for the rights of individuals over the power of the state. So that's an important distinction between freedom and liberty. Yippers, it's your turn to play. Okay, so the first question. Assume that you are paid $1 for an 85-cent purchase. You would count back, starting with the amount they give you, which was 85 cents. You would go 90 and $1. So that means you would give them a nickel to get to 90 and a dime to get to $1. And so the answer to this question was written just like I did right here. The number I start with, and then what I'm how each of the coins added to get me to that. So now you have to do that with. So now you're going to do that with a 23-cent purchase, a 55-cent purchase, and a 3-cent purchase, and you're going to show me what the increments would be next. Just like I did, if you go back the screen, just like I did with the 85, 90, $1. Okay, that would be a nickel here and a dime to get to there. Okay. Okay, number 2, we're talking about commutative, and that means that the order doesn't matter. So if I had A plus B, that equals B plus A, because it doesn't matter if the A or the B goes first, the answer is still going to be the same. For example, if I had 2 plus 1 equals 1 plus 2, they both equal 3, so the order doesn't matter in this case, whether the 2 is first or the 1 is first. If it's A times B, change that to a times sign. 2 times 1 is 2, 1 times 2 is also 2. So in this case, again, the order doesn't matter. The question here, what it wants you to answer is if you have a union of sets. And so this question is going to ask about the union of sets. So if we had in one set 4, comma M, and the union sign, and 4, comma L over here, we know that the 4 would go, we have that there, we put the M here, we put the L there. So all the union means that each of the separate ones, we don't do duplicates, are represented down here in the answer, and I would put my little brackets. So the question is, do you think, looking at what I showed you before, A plus B, B plus A times B equals B times A, where that order didn't matter, does it matter if the order here, if I do M4, L4, would that change the answer differently than that? And for this you can just say yes or no. If you think that this problem that I gave you, if you think it's commutative, then just write yes, and if you think it isn't, then you can write no. Okay? Problem number 3 is 6 squared, and I'll give you a little hint here. If I was asking you to solve 4 squared, that would mean 4 times 4, because the 2 tells you how many times this is multiplied. So we have 1, 2, and then we would solve 4 times 4. So what is the answer up here of 6 squared? And question number 4, let's see. Well, I'll just go to the next page and do the number. Okay, so for this problem, it's saying we have a total purchase that costs 684 cents. And each item that was purchased, so let's just say it was, okay, so total purchase of 640 cents for each of these party hats, and each one costs 9 cents. Yeah, it's flying around. But the question becomes, you have the total, which is 684 cents, or we could say $6.84, and we know that each one costs 9 cents. So we have to, how do we figure out how many of them somebody bought? Because we have the total and we know what each one has. So when we have those bits of information, we have the total and we have what each one costs, then we need to divide. So you need to divide 684 by 9 and tell me how many hats Sam bought. Okay. Okay, so now I want you to do a row of practice, and you'll have to number these problems. I didn't really number them. Okay, the first one is 84 plus 48. The second one is 347 minus 9. The third one is 53 times 6. The fourth one is 698 times 4. And then on the next page is 749 plus 962. 5. And then 6 is one of those long ones. 912 plus 742 plus 316 plus 25 plus 10. So work these out. Use the best method that works for you. And if there's still time when you're done, you can do Learning Farm while the others finish their math. Okay?